Pre-AP Unit 1 Retake Review. All right, we're going to start with number 1. In number 1, we need to simplify the expression, and we know that we want to combine like terms, but we cannot. We cannot do that until the parentheses are gone. So the first thing we're going to do is we're going to get rid of the parentheses, and we do this with distribution. So we've got the 3x squared in the front, so nothing's happening there. We're going to leave it alone. But we have to get rid of the parentheses around this expression, so we're going to distribute a 1 because there's no number given to us. All right? So we've got 1 times 5x giving us positive 5x. We've got 1 times negative 7x squared giving us negative 7x squared. Right? They stay the same. Then we have plus 10, and then we have this group here, which is getting distributed a negative 1 into it, right? Negative 1 does change things. So we're getting negative 1 times 7x, which is a minus 7x. Negative 1 times 4, which is a negative 4. Once your parentheses are gone, now you can combine like terms. And I've got a negative 7x squared and a positive 3x squared, which I combine to get negative 4x squared. And then I've got a positive 5x with a negative 7x. This is going to give me a negative 2x. And then finally, I've got my constants, which are just a positive 10 minus 4, which we know is a positive 6. And that's as much as I can do because there are no more like terms. Problem 2. We've got something very similar here, only now we're going to distribute with possible changes in exponents, right? When we multiply 2x times x, let's remember that each of these x's has an exponent of 1. And we know that when we multiply an x times an x, their exponents are added. So here we're going to get 2x squared, okay? And then we're going to keep going. Well, 2x times negative 3 is just negative 6x. And now we move on with the negative 4x. Negative 4x times x, very similarly to the first term we did, it's going to be negative 4x squared, right? Each of these has a 1 to add together. And negative 4x times 7 will be a minus 28x. Now we can combine like terms. I've got a positive 2x squared and a minus 4x squared. It's going to give me a negative 2x squared when I add. And I've got a negative 6x minus 28x. And here I'm going to get a minus 34x. These are not like terms, so we cannot combine them further, and that's our answer. Problem number 3. All right, in problem number 3, we need to write this in radical form. I would really encourage you guys to separate it as thinking about this as 4 times x to the 1/4, right? And then with that term over there, we need to remember our rule. Well, we have a to the m over n is equal to, n is our index, a to the power of m. And this formula is on your formula chart, remember? So really we have 4 times, and then we follow this pattern, right? Our denominator becomes our index number. So my denominator is going to become my index number, right? And then I have x, and then I have to look at my exponents. Well, we see a 1 up top here, just like the m is up top, and that's becoming the exponent on my base inside. So I know the 1 goes here. All right, so I'm going to clean this up a little bit. I'm going to write 4. 4 is my index with x to the power of 1, which we know we don't have to write that exponent if it's a 1. And there's my answer. Problem 4. All right, in problem 4, this is the power rule. On your formula card, it looks like this. A to the power of m in parentheses to the power of n is equal to a to the power of mn. All right, since there's no symbol in there, we know they're multiplying. We've got a couple more things in here than just a, but the big idea is that everything in here is going to be to the power of 1/2. So 9 is going to be to the power of 1/2. X to the 6th is also raised to the power of 1/2. And y to the 10th is also raised to the power of 1/2. We're allowed to do this because this is just a monomial inside of here, right? So we can raise every piece of it to the power of 1/2 to get our answer. All right, 9 to the power of 1/2, you may know this off the top of your head. However, if you don't, you can always check in your calculator, right? We have 9 to the power of alpha y equals here. I'll make it look like a fraction, 1/2. Okay, you should know this is the same as square rooting the 9, and we do get 3. So we get 3. Now, just like here, when we have exponents touching each other like this on either side of parentheses, we multiply them. So 6 times 1/2 gives me my new exponent for x, which is going to be 3. And then on my y, 10 times 1/2 is going to give me 5. And this is my final answer. Okay? All right, problem number 5. Here we go. Problem number 5, we are dividing. All right, let's set up our answer. And let's also remember our two rules we do when we do these problems. First, we ask ourselves, when looking at our exponents, where is it bigger? Right? Where is it bigger? And the second question we ask is, okay, once we know where it's bigger, how much bigger? Right? How much bigger? And that's our exponent. So I'm looking right now first, though, at my 30 divided by 5. These are regular numbers. They divide normally. 30 divided by 5 is 6. I'll put a 1 on the bottom to hold my place, just in case. All right. What else have we got? Now let's look at our a's. We've got a to the third power over a, which we know has an exponent of 1. And we say, okay, where is it bigger? Well, it's bigger on the top, so a goes on the top. How much bigger? In other words, how much more is 3 than 1? We know that exponent will be 2. Okay, now we're going to look at our c's, and we see that our b's. We've got b to the power of -2 and b to the power of 7. Well, we know it's bigger on the bottom, so b goes on the bottom. How much more, though, is 7 than -2? If this is giving you trouble, think about money, right? I have $7 in my bank account, but you're $2 in the hole. I actually have 9 more dollars than you do because you got to dig yourself out of your hole first, right? 9 more than 7. And now if we look, 9 more than -2. Now if we look at our c's, we see that they are exactly the same exponent, in which case they cancel each other out. So my final answer here is 6a squared divided by b to the 9th. Okay, problem 6. Next page, flip it over. All right, we're writing an expression for the perimeter below. Let's remember we have a formula for perimeter of a rectangle. That is 2w plus 2l. Okay, so I'm going to use my formula. Let's first distribute this to make it a little bit easier. 2x times 2x is 4x squared, plus 2x times 7 is going to be 14x. And now I can use my formula, right? So I'm going to say P equals 2W, so 4x squared plus 14x, plus 2 times my width, which is x minus 2. All right, sorry, I had to. Here we go. All right, we're going to go ahead and we're going to distribute. So we're going to get 8x squared plus 28x. And now we distribute this 2 over here, so plus 2x and minus 4. Now remember, we're not done until we combine like terms. So my like terms for these, I've got positive 28x and positive 2x. So 8x squared is in the front, now I've got a plus 30x, and then minus 4. There we go. All right. Don't confuse perimeter with area, right? On the next one, we've got area, and we know to use base times height divided by 2. So we're going to multiply our base times our height. Okay? So I'm going to take my area formula, and I've got my base 7a to the 4th, b to the 3rd, c to the 6th, times my height, which is 4a, b to the 5th, c to the 10th. And I get to divide all of that by 2. But before I start worrying about that, let's just look at the top. All right, let's multiply this just on the top. So we're going to have 7 times 4, and we're going to get 28. And now let's look at our a's. Remember, we add our exponents in a situation like this. So 4 plus 1 is 5. Now we're looking at b's. We get to add 3 plus 5 and get 8. And finally, our c's, we get to add 6 plus 10 and get 16. Don't forget, this is still all over 2. Now, 2 is a constant. It's a regular number. So we divide it only with the 28 up top, not with the exponents. So my final answer here is just going to be 14, A5, B8, C16. Okay, problem 8. Problem 8 is another area problem. However, we've been given the area. The area is, so this 21 thing is my actual area. I'm going to label it in my box. So 21x y squared z to the power of 3. It says find the length if the width is 7x y z squared. So what that's telling me is I don't know this side, which usually I would multiply this times this to get my area, but I already have my area, so I have to work backwards, which means we are not multiplying, we are dividing. So take your whole area, and you're going to divide it by the piece that we have, which is 7xyz squared, to get the piece that we are missing. Okay? So 21 divided by 7 is going to give me 3. So I'm going to do 3 over 1. Then we're looking at our x's. Okay, well our x's are exactly the same, right? So they cancel each other out. My y's, I've got y2 on the top and y1 on the bottom, which means that they are bigger on the top. So y goes on the top. How much bigger? Just 1 bigger. Same with my z's, right? They're bigger on the top because 3 is bigger than 2, and they're only 1 bigger. So my final answer here is going to be 3yz, right? I don't need 1 if it's a denominator, and I don't need those exponents if they are 1. All right, problem number 9. Simplify the expression. This is very similar to problem 2. It's actually fairly similar to problem number 7 in the process here. We're going to multiply these two together. All right, we've got 4 times -5. Those are regular numbers. We multiply them normally and get -20. And now we've got x to the power of 3 times x to the power of 4. We're going to add those exponents and get 7. And now I'm looking at my y's, right? So we've got y and y to the -2 times y to the 4th power. Remember, you're adding the exponents, so you do not get -8. We add -2 plus 4 and we get a +2. And this is my final answer. Finally, problem 10. In problem 10, we're trying to add two terms with square roots, but we can't do it right now because 20 and 45 are not the same. Remember, if you're going to add two radical expressions, you need to make sure that you have the same numbers inside, okay? So we're going to go ahead and try to simplify, and I'm going to use my factor trees here. 20 is really 4 times 5. 5 is prime, so now we look at the 4. Well, 4 is 2 times 2. All right. The 3 was already given to us, and now I've got 2 times 2 times 5 for my prime factorization of 20. Remember, we're looking for pairs here, so I got a 2 outside because I had a pair of 2's on the inside. We just write it once out there, and we're going to multiply those. So we got 6 square root of 5. Now the 45, we're going to do the same thing. I'm going to use 5 times 9, and then 3 times 3. And I already had the 2 outside, right? That was given to me. And I've got 3 times 3 times 5. All right, I've got a pair of 3's this time. So 3 goes outside. Multiply those out there. We've got 6 square root of 5. So we're trying to add these together. Well, now our numbers inside match. Okay, yes, the 6's match. That was just a coincidence. That does not normally happen. We don't really care if those match right now. We need the insides to match, and they do. So now we can add up the outsides, and we're going to get 12 square root of 5. Please make sure that you can do all of these problems independently, right, on your own before you try to retake. Your retake will be very similar to this. These are the skills that you need. Good luck.